What if I told you that the forest isn't just a collection of silent, solitary giants, but a single, interconnected system? And what if I told you that right beneath our feet, there's a kind of biological internet? A network where ancient trees have been moving information across the entire forest for millennia. We've known about this wood wide web for years. We thought it was mostly for sharing food and water, like a quiet, cooperative society. But we've started to listen more closely. We've begun to eavesdrop on their private channels, and what we're hearing is changing everything. They aren't just sharing. They're not just cooperating. They are sending out urgent warnings. And they're all warning each other about the same things. To really get what we're just now discovering, you need to understand the world as we knew it. For most of history, we saw a forest as a place of competition, a ruthless Darwinian battlefield where every tree fought for its own patch of sunlight and water. The strongest would shade out the weak, the fastest growing would starve its neighbors. It was a simple, brutal, and honestly, a profoundly lonely picture of nature. But that picture was wrong, utterly wrong. The revolution in how we see forests began with scientists like Dr. Suzanne Simard, a forest ecologist who had a hunch there was more going on. She spent decades in the vast forests of North America, not just looking up, but digging down. And what she found would rewrite biology textbooks. She found the Wood Wide Web. So, what is it? Imagine an internet made not of fiber optic cables, but of life itself. It's built from unimaginably vast networks of fungi, specifically something called mycorrhizal fungi. These aren't the mushrooms you see on the forest floor. They're the microscopic thread-like filaments of the fungus, called mycelium, that stretch for miles, like a living lace woven through the soil. These fungal threads don't just grow near the trees. They fuse with them. They form a symbiotic, a mutually beneficial partnership with the roots of almost every tree in the forest. The tree uses photosynthesis to make sugar, energy from sunlight. It sends as much as 30% of that precious energy down to its roots to feed the fungus. In return, the fungus, with its huge, intricate web, acts like an extension of the tree's own root system, but 1,000 times more effective. It scours the soil for vital nutrients like nitrogen and phosphorus, and most importantly, for water, and pipes them back to the tree. That alone was a game changer. But the truly mind-bending part was that this network didn't just connect one fungus to one tree. A single fungus can connect to dozens, even hundreds of trees, sometimes of completely different species. A huge Douglas fir can be linked to a delicate paper birch. This is the Wood Wide Web, an intricate underground marketplace. Through this network, trees aren't just taking, they're giving. Dr. Simard's famous experiments used radioactive carbon isotopes to track the flow of resources. She proved for the first time that older, more established trees were sending food through the network to younger, struggling seedlings that were shaded out on the forest floor. They were nurturing the next generation. These giant ancient trees at the center of the networks became known as mother trees. They are the hubs, the critical nodes in this biological internet, connected to everything around them. Studies have shown they can even recognize their own kin, sending more resources to their direct offspring to help them survive. We've even seen dying trees dump their remaining carbon into the network, a final act to support the community after they're gone. The forest wasn't just a collection of individuals. It was a community, a cooperative. One of the most radical interpretations, as Dr. Simard herself has said, is that a forest behaves like a single organism. This was the beautiful, complex system of sharing and support we thought we understood. But this quiet cooperation is only half the story. It's the baseline conversation. We were about to find a much louder, more urgent message hidden in the network. For years, scientists focused on what was being shared through the Wood Wide Web, the physical stuff, the carbon, water, and nutrients. It was like a postal service. But what if it was more? What if it wasn't just a physical internet, but an information internet? We already knew trees could communicate in other ways. When a giraffe chews on an acacia tree, the tree releases ethylene gas into the air, a chemical scream. Nearby acacias detect this gas and immediately start pumping bitter tannins into their leaves, making themselves taste awful before the giraffe even gets to them. But that's a localized, airborne warning. Could a message travel further, with more precision? To find out, scientists had to move beyond tracking resources. They needed a way to listen to the signals themselves. This is where the hack comes in. It wasn't a computer hack, of course. It was a feat of bio-snooping, using incredibly sensitive new tech to eavesdrop on the hidden language of the forest. Scientists started deploying sophisticated sensors, using techniques to track not just the flow of nutrients, but the movement of specific chemical compounds, the very molecules that act as messengers. They were essentially tapping the lines. But the real breakthrough came from listening to a different kind of signal. Electricity. Yes, electricity. It turns out that trees, like all living things, have electrical potential. For a long time, this was dismissed as biological noise. But as researchers started attaching highly sensitive sensors directly to trees, they found that these slow-pulsing electrical signals weren't random at all. They were part of a complex, voltage-based signaling system, stunningly similar to how our own nervous systems work. The hack was successful. We were in. And the messages we were about to intercept would be far more alarming than we could have ever imagined. What scientists discovered was that this network wasn't just for sharing sugar. It was an alarm system. When a tree is attacked by a pest, like a pine bud worm, it doesn't just fight back alone. It sends out specific chemical distress signals through both the air and, crucially, through the mycorrhizal network. These signals are the forest's version of a 911 call. One study showed that when a bean plant was infested with aphids, it sent a message through the fungal network to a nearby healthy bean plant. That second plant, without ever seeing a single aphid, started producing chemicals that repelled aphids and attracted their predators, the wasps. It was preparing for an attack it hadn't even experienced yet. This is a coordinated preemptive defense. The same thing happens with drought. A tree experiencing water stress sends hormonal and electrical signals through the network, a warning that resources are scarce. Other trees that get this message can respond by closing the pores on their leaves to conserve their own water. It's a community-wide conservation effort, triggered by a single suffering member. This is the unified distress signal. It's not just one signal, but many. A complex language of chemical and electrical pulses, specific to the threat. An insect alarm, a drought warning, a disease alert. Each one is a specific scream that puts the entire ecosystem on high alert. Now, it's important to say that this is a very active field of science, and there's a healthy debate about how widespread and intentional this communication is. Some scientists argue the story may have gotten ahead of the science and that we need more evidence from real-world forests, not just labs. But the evidence that trees are interconnected and can transmit complex signals is growing. What we mistook for a peaceful marketplace was, in fact, also a battlefield command center. A kind of distributed intelligence, with the mother trees acting as key nodes, the memory banks holding ecological knowledge and helping to guide the forest's collective response. We thought we were listening to trees share lunch. We had stumbled upon something far more profound, the forest's immune system. And with the pressures of a changing world, those cries are getting more frequent and more desperate than ever before. This discovery that forests can act like a single, coordinated system with a collective voice forces us to ask a tough question. What have they been trying to tell us? The answer is written in their bodies. Ancient trees are not just communicators, they are living archives of environmental change. The science of dendrochronology, or studying tree rings, lets us look back in time. Each ring is a year of a tree's life. Wide rings tell of good years. Thin, scarred rings tell a story of hardship, drought, fire, insect plagues. These trees are the planet's hard drives, our most faithful historians. They have a form of memory, not a conscious one like ours, but one encoded in their biology. A tree that survives a drought might develop a more robust root system or become more efficient with water, a change that lasts for years. And what do these archives tell us now? They tell us that the stresses they face today are different. The distress signals are firing more often and with more intensity. The threats are no longer just a local pest or a seasonal drought. The entire system is under chronic stress from human-caused climate change. The mother trees, the hubs that hold the system together, are themselves under unprecedented threat. When these ancient trees die, it's like shutting down the main servers of the network. Communication is disrupted, resources aren't shared as effectively, and the entire ecosystem's resilience drops. Think of Pando, the trembling giant in Utah. It looks like a forest of 47,000 aspen trees, but it's not. It's a single organism, genetically identical, connected by one massive root system. It's thought to be tens of thousands of years old, one of the largest and oldest living things on Earth. And Pando is dying. For decades, there's been almost no new growth. The community is all senior citizens, with no kids to replace them. The cause is a complex breakdown, largely due to overgrazing by animals whose natural predators have been removed by humans. Pando's struggle is a perfect tragic example of what's happening to forests globally. The delicate balance is broken, and the entire organism is starting to fail. The implications are staggering. We aren't just clearing collections of trees, we are dismantling a living network of communication and resilience. The forest's distress signal isn't just for other trees, it's a message for us. These ancient beings, which have survived ice ages, are now sending a warning that the current changes are happening too fast. Their collective cry is the planet's fire alarm, and it's been ringing for decades. We just finally learned how to hear it. We started this journey seeing a forest as a bunch of wooden pillars. Then we discovered the hidden wood wide web, a biological internet quietly sharing resources. But the final revelation is the most profound. A forest acts like an interconnected organism, an entity with a memory stored in its elders, and a voice that can cry out in a unified chorus of distress. We have eavesdropped on the Earth's oldest conversation and intercepted its oldest warning system. The message is crystal clear. The network is under attack. The life support systems are failing. This has to change how we see the world. That tree in your backyard isn't alone. It's a terminal, plugged into a planetary network we are only just starting to understand. Fighting to save a single old-growth forest isn't just about preserving biodiversity. It's about saving a piece of the planet's nervous system, a vital hub in this global web of life. The trees have always been sending us messages, written in their rings and broadcast on chemical and electrical wavelengths. They've been warning us for centuries. We were simply deaf to their language. Now we can hear them. The question is no longer what they're saying, but whether we will finally choose to listen. The first step to protecting these incredible systems is awareness. If this story has changed the way you see the trees around you, please share this video. Let's spread this knowledge. And next time you walk through a forest, take a moment, pause, and listen. You are not alone. You are in the presence of a vast, ancient intelligence. Let's work to ensure its voice is never silenced. Let us know in the comments what this discovery means to you. And for more deep dives into the hidden wonders of our world, make sure to subscribe and turn on notifications.